Hello again! Welcome back, my favorite coder cats and coder kittens. As usual, this is Becca, going by Nightcats Meow most places online, welcoming you back for us to talk again for another week about Linden Scripting Language. And this week we have one of the slightly unusual episodes. This week we're going to look not just at specific code, but how a combination of code, design, and multiple things that you implement with that code at the same time can construct an overall better effect within SL. So we're going to look at something I did. Some of you may realize that I do a lot of roleplay sims on SL. For a while I was trying to run a superhero one, and I heavily modified an ASI prosthetic arm, just a basic cyber arm, for this character, and decided to give it a built-in weapon, and took their concept for built-in blades and changed them around to come out of a different location and be retractable and a whole bunch of other things, and have a taser effect. And I've gotten quite a few compliments on the electrical effect on them, so I thought I would go ahead and look at that this week, show how the effect is generated, and how utilizing multiple features at the same time really help to convey the effect. So we're going to look at this arm right here as our subject of interest for the week. And that shock effect is the very one that I wanted to discuss. Starting with some of the most obvious is that the adjustment of the figures in preparation to move, that is all controlled back in the primary script. Some of this is going to make a lot of sense, some of it is not, but it lets us cover a few different interesting details. The link primitive parameters fast, by this point, most of y'all should be pretty familiar with that. Prim position local, prim rotation local, prim size. All fairly straightforward, all easily understood by having a look at the set primitive parameters wiki page. Now, what may seem a bit weird is that on each of these it says LP7, LP14, what have you, and that there's a list up here. Here we establish an integer LP21 equals 2, LP22 equals 3. This allows these numbers to be a stand-in for the link number in the set link primitive parameters fast. And every one of these pieces that is to be interacted with is tagged with a link number. Link prim 18 in this case. The reason I did that is because if I added or removed any pieces down the line in order to expand or add to or take something off of this, I have a simple program that will just go through and generate this list for me. This means that I don't have to go through and get the link numbers for each piece individually again. I can just run that, get this list, and move forward with my life. No more complication. But that brings us down to, each of these sections basically just details what I want each piece to do in order to achieve the effect. Those fingers come in, it's each of these one at a time goes through, does its thing. These two pull back the blades. This starts to go through and move the fingers, so on and so forth. Very simple, not all that fancy, not all that interesting. The interesting part is right here in the flash integer x. On the timer, when they're extended, X23, because that was sort of the inspiration for the positioning of the blades. If you're a fan of Marvel Comics or saw the movie Logan, the X23-2 clause, that just sort of inspired the variable name. That says whether they're in or out. When they are out, I set a timer event. the first thing it does down here, one thing to remember is that perfectly consistent is perfectly artificial. So I establish rate of 1, which is important here, because that goes into an llFrand. That is a random number calculator. It will give me a random number between 0 and 1, or a random float between 0 and 1. So from 0.01, 0.001, 0.5, what have you, anything in that range can be generated here. And that changes how often this timer event is going to trigger. Every time it triggers, it randomly determines where in that time frame between between like a hundredth of a second and a full second, somewhere in there, it will trigger. That randomness helps it seem more natural, helps keep it from seeming obviously artificial. The next thing it does is it creates an integer, choose equals llRound ffrand 4. Since ffrand produces a float, which can be any decimal point in that range, llRound rounds that up or down to the nearest whole number, so I can use it as an integer. And then it checks, is that integer 0, 1, 2, 3, or 4? And then it runs a command I've created called flash with an appropriate link primitive designation, which you recall back up here was established just to make my life easier should I ever add or remove anything. So the flash command, it plays the sound. That was that electric zappy noise that you heard. Then it sets link parameters x. You see up here I have an argument, integer x, and in here I provide an argument in the form of the name of a link number. The name equals the actual number. And then it's prim color, all sides, because there isn't a way in the set link primitive parameters to just do alpha level. You have to do it as an effect of color. So I establish the color with an alpha of 1. That's full visibility. Prim point of light, true, in a color that complements the color that's established there. All of those settings. And then prim glow, all sides, 0.6. After literally 1/10 of a second, it then turns all of that off. You notice that the prim color, all sides, is exactly the same except for this right here. This is controlling the alpha. Alpha 0 is fully invisible. Point of light is the same except for right here, false. That turns the light off. And prim glow sets to 0. And then after a random amount of time, it picks another one of those. So with 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So generously 17 lines. We create that effect right there. Each of them emitting light individually. This plays beautifully on an avatar if you're running advanced lighting model. It really does contribute to a sense of it being realistic. The mesh for the sparks, that is a separate individual mesh right there, is incredibly simple. I'm not particularly good with mesh, but I was able to create them very easily in Blender because they're mostly just a bunch of extruded lines just going out in oddball patterns. And it looks fine popping between them. You don't actually see their flaws because you don't see them long enough. That's one case where you don't necessarily have to have everything perfect. Here we can actually look at them. So you see, they're really just very simplistic batches of lines, just going off in weird angles all over the place. What makes it look this good is you don't see how simplistic they are, because you don't see them long enough. You see them for 1/10 of a second every time, and I could even shorten that. But they give off light, and they appear in a randomized pattern that helps it seem organic. And in most cases, unless you're staring right at it, somebody isn't going to see the repetition enough for it to start to break the illusion. So the point to this lesson is, one, to show you how combining different commands in llSetLinkPrimitiveParamsFast can give you a great deal of control over a specific item. In this case, each of these flashes is controlled with llSetLinkPrimitiveParamsFast. The extending of the blades and the folding of the fingers are handled with llSetLinkPrimitiveParamsFast. It's an extremely versatile, extremely powerful command. And because you can fill in so many different options, our alpha control HUD was handled through llSetLinkPrimitiveParamsFast. So the ability to take control of numerous settings on a specific object or part of an object in your LSL build will give you a lot of control. And I'm going to show you what this looks like actually on the avatar with all of that advanced lighting active. So give me a moment to go ahead and change avatars here, and I will be back. Hello, welcome back, and here I am. I believe for the first time showing up on this channel as something other than a large black cat. But don't worry, it's still your favorite coder kitty under the skin. And here just to give a look at what kind of effect this creates on a proper avatar under advanced lighting. So you see, it all plays together. The flickering, the lighting, it creates a more dramatic look on this character, more of a threatening appearance. That doesn't work when the hand goes inside the avatar. Creates more of a sense of what's going on. You intuitively understand that, yes, this is electrified shock. And there are different ways that this could be done. One of the most obvious ways one could try to use would be a particle system. Now, the differences with a particle system are you don't necessarily get them to go perfectly between the claws the way this does. Further, you don't get to emit light from the particle itself. So I stand by using a mesh piece here. Further, you could have used a flat prim with a lightning bolty texture on it, but the fact that these are mesh sparks traveling along those pair of claws allows the image to hold up perfectly from whatever angle you're looking at it from. So overall, I stand by my design decisions here. But that is kind of the point of these occasional designer episodes, is to think through how the code you're implementing and the specific pieces you're building with combine to create an effect that is greater than the sum of its parts. So, in this case, from a cyberpunky environment, a set of claws that can be used to slash somebody up or hit with the backside of them and tase someone. You might not particularly be into that itself. You may be into something magical or superheroes or what have you. But ideas like this translate into a lot of things. So, if anybody has specific requests for tutorials for next week, please feel free to post them in the Discord or in the comment section of the YouTube videos. Comments about the videos I've done. Do you particularly like these designer-focused videos? Do you want me to just never do these again and just focus on pure how do you build this with code and not tarry into the thought process of how the pieces fit together? Let me know. I make these videos for all of you. Those of you that are active and responsive on my Discord server and in the comments of my YouTube videos, you all are the ones that are going to be shaping these videos for everyone else. So I look forward to hearing from you. These videos, of course, the Coder Kitty workshop videos, of course, turn up every Tuesday by noon Eastern Standard Time. I also have my relatively new series, Coder Kitty Decoded, where I break down the specific syntax and structure of different commands and event handlers for LSL. Those should turn up Wednesdays, so from the day that you're seeing this, that will be tomorrow, and this one breaks down listens. So, all told, thank you for watching, happy to hear from you, please be well, good day, good luck, happy coding, meow meow.